Hello, everyone. Good evening, good morning, good day, wherever you are in this world. Hello and welcome. And thank you so much for joining for this Microsoft Reactor workshop this evening. It's evening for me. My name is Erika, and I am the program manager at Microsoft Reactor Stockholm. Today, we are kicking off with the Championing Azure series that is aimed to provide the necessary skills in Azure and is perfect for those that are early in their developer career. The series focuses on 3 platforms in Azure: AI and machine learning, cloud native, and DevOps. Throughout our hands-on workshops, we will introduce the basics of Azure and demonstrate what the platform is capable of. For the next 6 weeks, on Tuesdays, we have beginner content in AI and machine learning. AI Tuesdays, as I call it. Next slide. No, not that slide, sorry. That slide. So yeah, just before I carry on, I would like to just say a quick word about the Microsoft's Code of Conduct. We all come from different backgrounds, but we are all here to learn. So just please be aware of each other and be welcoming and respectful. Thank you. And now let's move on to the real reason why we are all here today. Let me introduce our speakers, Alan Smith and Peter Örneholm. Both Peter and Ellen are software developers, Microsoft MVPs, and they both work for Active Solution, a company in Stockholm helping companies achieve more using modern web and cloud technologies. Both Ellen and Peter are very active community event organizers here locally in Stockholm, leading events such as Cloudburst Conference or the Global Windows Azure Bootcamp, just to name a few. Today, I am so happy to welcome them and to kickstart this series with them, an introduction to Azure AI and machine learning. This session will focus on introducing you to the concept, terminology, and tools to get started with AI and machine learning on the Azure platform. Now, I think I've spoken enough, so let's bring you guys onto the spotlight. Here, Alan, there is Peter. Hi, hello.
Hi.
Thank
Hello.
you so much for being here. Yeah, I think I've spoken enough. We have limited time, so I'm just going to be, in the background. I'm gonna remove myself from the stream. So you guys up, but yeah, just so much thank you for being here today. I really appreciate it. Yeah.
Thank
So,
you, Erika. And let me just start sharing my presentation. Yeah, thank you for inviting us to this session, and thank you for letting us share our passion, which is a lot of stuff, but especially Azure and AI. And before we dive into all of the goodness regarding AI on Azure, let me just quickly give you an overview of what this session will be about. First, I will give you an introduction, both to quick introduction to who we are, but also to the concept of AI and machine learning on a high level. Then we will guide you through using demos the 5 levels of AI development, which defined by Alan is applications, services, models, frameworks, and algorithms. And at the end, there will be time for questions, and we will make our best effort to answer them. But please, if you have any questions along the way, please just write them in the chat, and we will be able to see those questions and pick them up at the end and give you answers to those questions. And just a quick intro on who we are. As Erika mentioned, we are consultants and software developers working at Active Solutions. And we have software developers primarily in Stockholm, but we also seek for people all over Sweden. And we love to solve our customer needs using technologies such as Azure and AI. Enough about that. And let's go over to the AI and ML, which is what we are here for. If we look at Wikipedia and kind of boil the text down, which is the article about artificial intelligence on Wikipedia, we can read that artificial intelligence is the ability of a computer programs to mimic the natural intelligence of humans, primarily the cognitive functions. So I would say that the artificial intelligence, according to this definition, is the ability for computer program to do things that previously was unique to humans. For example, understanding what's in a picture, understanding what's being said by another human, understanding the intention of what a person is saying at the moment, and things that previously wasn't able, that a computer traditionally haven't been able to do, because computers works with zeros and ones, and traditionally it was very hard to achieve these things. And you could say that programming a computer, traditional development, involves data and rules. You have data, such as images, or you have a video stream, or you have audio, and then you have rules. So for example, if you were to ask a computer, is this picture of a cat? You would give it an image of a cat, and you would have a rule saying a cat should have 4 legs and a tail and a head, and a cat looks similar like that. And then you do some development, you get the answer. And that requires a lot of rules, because there is always exception to the rules, and there is always it's kind of hard to do all of the rules for an animal, or if you think broader, it's hard to make rules for all possible scenarios. But with machine learning, you could flip 2 of these arrows, and instead saying, we have data, we have thousands of images of cats, and we say that or maybe we have thousands or tens of thousands of images of animals, and we say that these images contains cats, and these images contains dogs. And then the machine learning part can start to kind of learn the patterns, learn what differentiates a cat from a dog and so on, and come up with the rules. And that's kind of on a really, really high level. But you could think of it that these 2 arrows are actually being shifted when we're talking about machine learning. And I usually ask, how do you think you encounter AI in your everyday life? If you have 1 or 2 examples, please write them down in the chat, and I will be able to see what you are writing. But a few things that I know people do encounter, even if they know it or not, is that, for example, you might have one of those smart assistants at home. I have actually one in almost all of our rooms at home, so I can ask, well, what's the weather today? Can you please turn up the volume? Can you please play this music in that room, and so on? And my daughter, which soon she is 5.5 years old, she actually has learned to master this very good. So she's fluent in talking to this, and she controls the TV, she controls the audio, and she turns on and off the lights with her voice. AI is usually used to do subtitles for some TV shows and for some movies and YouTube videos, for example. AI and modern AI and machine learning might be the one that provides the spell checking in your application of choice for writing. When you're searching for images on the web, you might be searching for, I want images of Sweden, and then a modern search engine will be able to identify what's in this picture. There seems to be landmarks from Sweden, so this image is probably from Sweden. If you look in your phone for images, you might be able to do face detection to see that I want all of my pictures, all pictures of my daughter, for example, or my grandma recently passed away, and then I was able to, when I wanted to kind of show pictures from her during the years, I was just able to ask my phone, give me all of the pictures of my grandma, and I was able to scroll them through and remember her. And that's one of the features that AI can be used for. And for example, you might be using a spam filter in your email inbox of choice, and a modern spam filter is probably powered by AI to be able to distinguish what you think is spam, while another one might not think that is spam. And speaking of modern applications, Outlook is one of the services provided by Microsoft. And today we are looking at AI and machine learning from a Microsoft platform point of view. And Microsoft have a lot of services, both targeted towards end users, consumers, but also targeted towards towards businesses. We have Outlook, we have Azure, we have the Office platform, we have Teams, we have Windows, we have the Bing search engine, we have Xbox. Pretty much every topic you can imagine, Microsoft probably have a service in that area. And a lot of these services have been enhanced using AI and machine learning for the last couple of years, or probably even longer. So Microsoft have built up a huge knowledge within this area. And a lot of the things we will be looking at today are products or are things that kind of came out of those experiences. One of them are cognitive services, and I'll get back to that later. But speaking of that, I'll hand it over to you, Alan, to kind of give us an introduction to the things we'll be looking at today. And as you mentioned it, or as you call it, the 5 levels of AI development. Over to you, Alan.
Thanks for that, Peter. I'm just going to set up the screen sharing.
Yeah.
Okay, so hopefully
I think we lost your microphone there, Alan. No, you're back. Now we lost you again.
We can only hear you if I add this one as well.
Sorry, do you hear me okay?
Now I can hear you.
Yeah, because I added his other one, but if I remove this, now we can't hear him. Say something, Alan. Yeah. So we need to have that one there.
Okay, yeah. Okay, so this is a concept, this 5 levels of AI development, that I came up when I was thinking about AI problems and the different ways that you can solve these problems and the different types of levels that you can think about. The easiest way to work is with applications. This is when you're typically using a user interface to access the technology. You don't need to know anything about programming. You don't need to know anything about AI or algorithms. And a good example of this, which I'm going to be demoing after this slide, is the Azo Video Analyzer. Next, we've got the services tier, and this is what Peter's going to be talking about, working with cognitive services. So you do need to know a bit about code here. You need to know how to call an API from whatever programming language you're working with. But once you can make the API call, you can then access these services that are providing AI as a capability, as a service. You don't need to know about models. You don't need to provide any training data because the models are provided as part of that service. Next, we can go down to working with our own models. And this is when we are going to be responsible for selecting our training data, which, as Peter mentioned, is going to be thousands of images of cats, thousands of images of dogs, or various documents or sales data. And we're responsible for selecting a particular model and training that particular model. We can jump down a level. If you've been working with AI, you've probably heard people talking about Python and PyTorch and Keras and TensorFlow and all of these wonderful machine learning frameworks. And we can go down to that level if we like. We take a bit more responsibility because we've got to select the model, in some cases design the model. And we also take the responsibility for testing and tuning those models. So we've got a lot more responsibility there. And then down at the lowest level, we can actually work with algorithms. And this is really for hobby developers to learn more about how machine learning works. Or, if you want to study a PhD, there's certainly good openings there for improving on the existing algorithms. So this is really research, cutting edge, state-of-the-art development. If you're going to be working with this, you need to understand a lot about maths, linear algebra, also quite heavy programming skills, including working efficiently with GPU programming. So what I'm going to demo quickly is the Azo Video Analyzer, which is pretty much sitting at the top of that stack, where it's an application that we can work with. So the idea of Video Analyzer is we can use a portal, we can upload a media file. Now it is called the Video Analyzer, but it does work well by analyzing audio files as well. And it could also, be equally used with audio as well, but it also supports working with video. So we'll provide object detection. It will identify objects within that video, it will do face detection and identification. So it will identify faces within that video. And you can train it with specific faces as well to recognize those. Closed captions, it will generate subtitles for you by doing the speech to text. And then it also gives you the option to be able to translate these closed captions into other languages using translation services. We can also do sentiment analysis. So it will tell you, how people are reacting in the video as well. And, if people are happy or sad or various emotions that are coming into play. So I'm going to do a quick demo of this. If I switch to my browser, I've got my portal here on the Azure Video Analyzer for media. And you can see that the URL for this is videoindexer.ai. Now, this is free to try. If you'd like to try it, you can sign up for a free trial, and you get so many minutes of a video that you can encode. And uploading a video is very easy. I can just click on upload. I can browse for a file. And then if I go down to my webcasts, I produce a lot of webcasts on YouTube. I can go to the out folder, and I just published one on cloud computing in Microsoft Azure. So I can take that and I can upload that particular video. Now, it does take a while to do the encoding process, and I'm really limited for time in this demo. So previously, about 10 minutes before this session started, I uploaded this video here. Now you can see that I've uploaded other videos and I've trained it on my face, so it's recognizing me.
In this webcast,
appearing in this video. We've also got the timeline, and you can see here if I play
to show you how to set up an environment using PyTorch and CUDA. So on the PyTorch homepage, I'm going to click Getting Started.
So you can see that it's generated from my speech, it's generated the text, and I should be able to turn on the closed captioning here. And you can see there
we've made it really easy to set up.
I'll just drop the mute on there so you haven't got like two instances of me talking. You can see the subtitles are coming there. I can also do translation. So if I want to, I've no idea. I've heard there's people from all kinds of different countries. So I'm just going to go on. I don't know if there's anybody from Japan, but let's just go for Japanese and see if it's going to do a Japanese translation of that. And then in the closed captions, I should be able to select Japanese there. And hopefully this will make sense to anybody who's watching who does speak Japanese. I have no idea how accurate this is, so please let us know in the comments if you do understand any of that text. So that's the closed captioning. Another nice thing, I've done some videos on celebrity detection using the Azure Cognitive Services. So if you go into this celebrity detection in Python, you can see that as well as me, it's also recognized celebrities here. It's recognized Elvis Presley appearing in this particular section of the video. And if we go here, you can see that Elvis Presley is appearing. So these celebrities is within the trained model. It will detect.
I think it's great.
So what it's doing also here is providing topics, face recognition, image processing. It's identifying various keywords that we've got out here, various labels. And you can see that I was 2.66% happy at these points during the video. This is the emotion detection and sentiment analysis that it's doing. It's also suggesting, screenshots. You've probably seen this in YouTube. If you upload a video, we've got the screenshot suggestions there. So if I go back here, you can see it's going to take it a few minutes to re-index this next video. That's basically why I uploaded the first one. Other videos I've got is my kids. I uploaded one video of my son, James, one video of my daughter, Jennifer. And then we can actually search for these people. If I search for James, it's going to query all of the videos that contain James within that video. If you're a bit scared by the face recognition technology, just paint your face. For some reason, it didn't detect James in this particular video here when James was having his face painted at his preschool. So that's basically, drawing a Batman on your face. You can pretty much defeat all of these, face recognition systems. So that's the way to go if you do want to evade those. So I'm going to hand back to Peter, who's going to jump one level down in this stack and talk about the cognitive services.
Thank you, Alan. I will continue in this presentation from here. There we go. So as Alan mentioned, when you go one level down, so to say, we are the ones to be able to create the services. As Alan mentioned, that what the service Alan showed you what had basically a consumer UI. You are able to log in using your Microsoft account, upload videos. You have a UI to work with that and analyze and can kind of get the result out of that. If we go one level down, we are the ones as software developers, we are the ones to be able to create those kind of services. But if we don't have thousands and thousands of images of cats, or we might not have all of the data to train a complete model ourselves, so we can use cognitive services. And cognitive services next week, next Tuesday, I think it is the 25th, I will do a session solely on cognitive services. So then we'll do a deep dive. But I will show you the one of the demos from that today, and that demo is regarding vision. And as I mentioned, Microsoft have a lot of services where they have built up a lot of knowledge, and a few of those knowledges are baked into services exposed as cognitive services. So these are AI services in Azure that we can pay for to be able to use AI in our services and create AI-enabled applications. And what I will show you is how we can use computer vision to detect what is in a picture. Maybe we have a system where people are, let's say we are creating an application where people can upload pictures of their animals, and then we might want to auto-categorize them as either birds or cats or dogs and so on. We can use AI for that. Maybe we want to auto caption images. Maybe we have a large set of images or visual material that we want to search. We might give us all images containing a car, or give me all images containing a red building in the background, for example. Or there might be that we want to identify famous places. For example, this is the Stockholm City Hall. But let's start with the bird example. I actually created. Let's go into a demo here. Some time ago, I actually created a site which you can try out yourself if you want to. It's called birdornot.net. That's actually a demo site for this specific technology. So if you provide it with a link to a picture of a bird, it will tell you whether or not it is a bird. So in this case, it says it's a bird, and it identified it as a penguin. We get some automatic description of this image, and we see a little box where within the picture it identified the bird. Also, let me show you. I found a picture of an owl here, so let's grab the link to that image and analyze that image. And as we can see here, it says, yeah, this is an owl within. It's 92.5% certain that this is an owl. And the description of this image is a small bird perched on the top of an owl. I'm not exactly sure if that's correct description or not. But the technology used to build this site is computer vision in Azure. And as I mentioned, cognitive services, that's utils for us developers to be able to incorporate AI within our applications. So it's mostly a set of APIs and REST services. And therefore, by default, there is no UI. There is no way of trying it out without actually knowing how to code and how to do that. But I have made an open source project which is called Cognitive Workbench, which is UI, or kind of basically a test bench for a lot of the APIs within cognitive services. So here we can provide a file or a URL to an image that we want to analyze. Let's start with analyzing a beautiful picture of Stockholm here in Sweden and see what it says. Sorry, I chose the wrong image. Let me do that again. I need to clean this up properly and do this. So here we go. So this is an image, and if you look to the right here, we see some extraction of what the service found in this image. So technically, it's a lot of raw JSON data. So if you're a developer and if you know this is what's returned from the service. So it's machine readable and you can act on it and incorporate it into your application. But I've also made it a little bit nicer to see here. So we can see, for example, the caption and the description of this image is a city next to a body of water. It tagged the image with water, sky, harbor, boat, outdoor, and so on. If we go down here, we can also see that it found an object. So within this box here, it says that I found a boat. These are the coordinates for the boat, and a boat is part of watercraft, which is part of vehicle. But let's look at another image over here. Because I'm usually really amazed by the automatic descriptions this service can do for images. So let's analyze another picture from Sweden. So this is a cabin in the Swedish winter, and this is pure done automatically, given only the image. It says that this is a snowy road with a house and trees and a green light in the background. And the tag says, yeah, this is outdoor, there is snow in the picture, we have a tree, mountain, and nature, and so on. And this information can automatically be extracted and really be used for indexing, for searching, for categorizing images. Let's look at the last image here before we move on to the next section. And that is, I recently moved out of kind of Stockholm city and to an island or a place called Ekerö, quite close to Stockholm. And every day when I go to work in the city, I still work in central Stockholm. But then I passed the castle for our Swedish king and the queen, and I just found a beautiful picture of them walking right next to their, what do you say, castle or their house. Let's see. It's just so now I think I'm not sure if it's taking time because it's analyzing or if it's let's give it one more minute. Yeah, there it is. So now this is the picture of the Swedish king and the Swedish queen. So now you can see that, for example, it found the tie of the queen there. It found I'm sorry, I can't. It's kind of too. Oh, there it is. It found a dog in the picture. It found one person there. It found one person there. It found a face. It did a guess on the age of this person. And she is actually famous enough. So it says Queen Sylvia of Sweden and a woman walking a dog. So it's not 100% correct here, but it's at least it identified her as Queen Sylvia. I'm not sure if there's any other. There are a lot of metadata here that can be used. It also, one interesting thing is that if you were to crop this image as a square image, it can provide you with the optimal way of cropping it. Yeah, let's move on to the next demo. But I just wanted to give you that these APIs can provide a lot of information on visual images and visual information. But sometimes you want to analyze something that it can't identify. For example, what if you're into analyzing windows, and obviously there were no boxes around these windows, but maybe you're in the window industry and want to find, give me all of the windows in this picture. Then there is actually another service within cognitive services called let me see, Custom Vision. So Custom Vision lets you train your own model. So here we can provide data. Here let's say we have a few pictures of windows, maybe 20, maybe 15, maybe 1,000. For a good result, you really need to have a larger data set. But what if we want to train and learn the system to identify things that are relevant to us? And then you could do that either by doing image classification, saying this is an image of a cat and a dog and a dog. Or you could say within this picture and within this box, there is a cat and there is a dog. and you need to provide the images and the data, and you need to provide the labels, so to say. And let's dig into the demo. I have prepared a demo for you here. Here we go. So the idea here is that some time ago I was playing Bull. I think it's called Bull in English. And as if you have ever played that, you come to the situation: who is closest to the jack? Is it this bull or is it this bull? I'd say it's quite hard to estimate given only the visual eye here. And of course, at the moment we just picked up, we took our shoes or something and tried to see who was the closest. But I thought, wouldn't it be possible to kind of create an app? You take a photo of the scene and it identifies all of the bulls and the jack, and then do some estimation on who is the closest. Unfortunately, there is no built-in model that's trained on bulls and jacks in the Microsoft Cognitive Services. So I had to do it myself. So I've uploaded quite a lot of images here of bulls and jacks, and then you basically tell it, saying, yeah, this is a bull, this is a bull, this is a bull. So you provide the labels for where within the picture are the bulls and the jacks. And we have a few images here that haven't been tagged yet, so I can help out saying this is a bull, this is the bull, this is the jack. Sorry, I made a mistake there. That's not jack, it's a bull, and so on. And once you have tagged a few images and specified where what areas belong to what, you do train the model and saying, hey Azure, please give this a thought. Try to identify the patterns. Try to learn what based on the data I have provided you. But that can take some time. So I've already pre-trained this model. So now then, if I provide it with the image I just showed you, which I took with my mobile phone while we were out playing Bull, looking at this one, and then I ask it to, hey, please predict what's in this picture, and then it will say that here is a bull, there is a bull, there's the jack, there's a bull, there's a bull, there's a bull, and so on. So you could use this then. You could use this to create some software which would calculate the distance between all of them and tell who is the closest. And maybe you could even, if you ever play this game, you know that the pattern on these bulls are different depending on what team you belong to. So you could probably train a model saying bull team 1 and bull team 2, and it could automatically try to tell what team is the closest. But this, I've used it to train it on different car models, to train it on different trees in the forest, and so on. So you could easily use it for different scenarios depending on your domain. And we got a question before in the chat regarding what if it says that this is a cat while you know it's a dog, and so on. And if you use the built-in model, the one I showed you with images of Sweden, you're basically left with what that does. And this is really, really important within AI and using AI responsibly, that you should be aware that these are not to replace humans, and it's not meant to kind of be used as a truth, because there will be mistakes. There will be times when it says this is a cat while it was a dog, and maybe mixing up a cat and a dog is not the worst thing that can happen. But if this technology is used in some other serious scenarios, there might be really bad. It might end up really bad if the results out of this is taken to take serious decisions, so to say. And of course, you can make that model better. You can train it on your data, on your domain, and make that better. But you should still be aware that it's not 100% perfect. There are scenarios where it might mix them up, so to say. But this service will at least provide you with the ability to train it on your data and to improve that model, still using kind of a high-level service where it's easy to train the data. It's easy. You don't need to know the low-level stuff on AI. But speaking of low-level stuff, and sometimes you actually need to know that. But with that, I will hand it to you, Alan, because I think you will drill down into the levels of AI.
Yeah, thank you for that, Peter. I'll just get set up with my my sharing again. I'm going to make sure I'm sharing audio because there is going to be sound on this this next session, hopefully. So as Peter mentioned, we've basically gone down quite a few levels now. We've looked at applications, we've looked at the services, then we've looked at training our own models. However, the computer vision service is great if you're working with image data for doing various things like object detection, image classification. But what happens if you want to work with music? And the scenario that I'm putting forward here is we'd like to analyze, this song here, Machine Soul, Nora Linian. It's actually composed or co-composed by Robert Falkinson, who's going to be delivering the last session in this series here. So we do have rights to be able to use his music. He's given us permission to use it. So this, hopefully, you'll be able to hear the music playing in the background. If you want, to build a system, like SoundCloud, where people can upload songs, and we want to automatically say what genre this particular music is, then we've got to start thinking a bit differently and doing more advanced things with AI. Now, if you've worked with digital audio, you'll understand, what a waveform looks like. This is that same song loaded into a program called Audacity. And here we can see the actual waveform for the song. I can play the song, and you can see the actual waveform here, the actual bits that make up the song. Now, this isn't great for analyzing. What we really want to do is to work with something which is called a spectrogram. So if I flip onto this image here, and we go back, if I zoom out a bit, if I can, and go back to the beginning on this, you can see that this is kind of giving the frequencies within the music. As the music is playing, we've got the different frequencies being represented, and it's this pattern that we're going to be analysing. Let's see if we can classify the music. So what I've done as a kind of hobby project is basically written some code in Python to be able to do that type of classification. So this is the slides just talking about the waveform and the spectrogram. And what I'm doing is taking a 5-second sample of the music, creating a spectrogram for that 5-second sample. And that's going to be an array of floating point numbers, which is 256 by 256 bytes. And what we'd like to get for the output of this actual algorithm is the actual prediction of what type of music it is. I've lost my mouse pointer. I'll just see if I can get it back onto the screen. It seems to have disappeared here, so I'll persevere with it as is. So what we're going to want to do is to build some kind of network or design a type of network that's going to take that input and it's going to give us the output that is a prediction. Now, I'm not going to go too much into the theory in this section, but what we're actually building is something called a convolutional neural network. This is the same type of network that Peter has been demoing. However, when Peter's been working with this in the computer vision service, it's kind of all abstracted from you. You don't get to see the network, you don't get to play with it and redesign it. And this is basically the design of network we're going to use. We're going to use some convolution layers, we're going to use some linear layers, and we're going to use something called a sigmoid function to help us to create this particular output. Hopefully, that's going to be able to make a prediction on the music based on that particular spectrogram. Now, all of this sounds really complex, but what I'm doing is I'm working with a framework called PyTorch. And this is the code that I'm using in PyTorch to be able to create that convolutional neural network. The first line, I'm importing a model architecture, which is ResNet 18, and this is actually a custom vision, one that's used for custom vision for doing like object image classification. And then the next line of code, I'm setting the input layer. You can see it's saying nn.conv2d, that's a convolutional layer. And when I'm selecting 1, I'm specifying that there's going to be 1 channel. Now, this network is built for colored images. So it normally takes 3 channels, red, blue, and green. But I'm just changing this to a 1 channel. So if you're working with black and white images, or you're working with, an image where there's only 1 channel in the input, then you just select them as being 1 input channel. And then in the output, when it says nn.linear, this is the output layer of the network. And I'm saying that the actual output is going to be 7. there's 7 different genres of music that I'm going to be classifying. And what I'm doing is I'm really focusing just on EDM, electronic dance music. So I've got chill step, deep house, drum and bass, melodic dubstep, progressive house, techno and trance. You could expand this to more genres if you'd like to, and also maybe those genres are a bit overlapping. You know, deep house and progressive house. Maybe there's quite a bit of overlap in those genres of music. So it's maybe not the best mix of genres. The next thing we're going to do is to train the model. So I've got some training data, and I'll see if I can show you that. I'm having real issues with my mouse. It's my mouse pointer seems to be disappearing, but this is the actual what I was using for training. And what I've done is I went around on YouTube and hunted around, and I basically found some, you know, like hour-long mixes, 2 hours of chill step, or 44 minutes of deep house, 55 minutes of deep house. So I'm use these as the actual training images. Now genre is very selective, very personal, so I'm just basically trusting that when it is the best of trance, this is going to be trance music, this is going to be techno music, and I'm really relying on the definitions of those 2 hour mixes just being specifically that genre. But it may lead to inaccuracies, so it may be worth putting in some more research into the actual training data. So the code to actually train the network is a bit more complex. So I've got a bunch of Python code in here that's creating the network, running through the various epochs or training iterations, and sending the outputs so we can actually analyze this. I'm not going to run this code now, but in one of the future sessions I will dig into how this works and how we can work with the basic training code. But it's fairly standard boilerplate code for training networks in Python. You could use the same code for training the neural network to tell between cats and dogs. It will be a very, very similar process. Okay, so looking at the output of this, what I've done is basically done the output as a graph. So I think this is, that's the actual WAV file. This is the actual video file. So what I've done, I'll drop the volume down a bit, is I've just basically generated a graph here in something called matplotlib, which is a Python library. And what it's doing here is it's analyzing the music, and it's giving the percentage prediction at the actual point in which we are at the actual music. So if I turn the volume up a bit, you can see it's going for melodic dubstep, and then that goes into a deep house at this particular section of the tune. What I wanted to do is to kind of analyze the whole tune and specify the different sections or different genres when you get transitions in music. You can see that a bit of trance came in when that drum bit came in. As if you go through the track, you can see that it is switching between genres. It goes into progressive house here, or it's predicted as being progressive house, and then goes back to deep house here. So there's great scenarios on this. If you've got a music service and people are interested in a particular music genre, being able to have all your music catalogued being selected based on this genre that you can classify using machine learning and using artificial intelligence is going to be really useful. And this is something you can do at home. It's not too challenging to build this code. There's plenty of examples available on YouTube. There's a great YouTube channel where I can share the link on that's talking about all of the theory behind this as well. And I'd say it took me a couple of days to build and train this network. And we will be covering how to do that in future sessions. And I'm going to basically round off also by going right deep to the bottom of the actual stack. What we've covered, if I can actually whiz back up to the 5 levels of AI section, if I can find it. Here we go. We've basically talked about applications with a video analyzer. Peter's demoed the cognitive services and the custom vision service, and then I've demoed using PyTorch to do the music classification. I'm going to jump down to the algorithms and talk a bit about the work that we can do when we're actually programming and building our own algorithms. And what I've become really fascinated with is evolutionary learning and genetic algorithms. And I've been playing around with self-driving algorithms. I've been really impressed by what Tesla and other companies are doing with self-driving cars. So this is using an algorithm which is called a genetic algorithm. I've got, I think, the code in here, this genetic algorithm class written in C# here rather than Python. And what this is doing is it's training cars to be able to learn how to drive. So here, I've got a test track, and what we're doing is we're sending out 50 cars to actually start driving around this track. And these are hopefully going to evolve and learn how to drive around the track. I'll just basically drop up the theory on this quickly whilst these cars are evolving. And if I drop back to the deck, whiz down to the section on genetic algorithms and evolution, and just run this deck here. If I can get down to the appropriate slide. Sorry about that. So what we're doing is we're starting with an initial population. We have some kind of evaluation. In this case, we're evaluating how far the cars can drive before they crash. We then select the cars that drove the furthest, and we're basically using a sequence of numbers to train their neural network. And we perform a bit of maths to do crossover and mutation to put in some randomness, and that then goes to the next generation. Hopefully, the next generation will have learned a bit more about driving. So this is basically what's going on in that algorithm. It's kind of mimicking the way that evolution works. And you can see that now we've got generation 4 being able to drive at 2000 pixels, and it's looking like this generation has actually solved the problem of being able to drive the car around the track. We can also basically play games with this. This slider here controls the friction. So if I go like this, that removes the friction, and the cars are now driving on ice. So this means that the model will have to adapt to learn about driving on ice, because there's very little friction here. And hopefully, if we run it through a few more generations, they should be able to adapt their driving style to do with a change in friction on the track. And you can see that car is now basically learning that sliding around corners is a good idea, and it's basically able to adapt its driving style to be able to adapt to the changing conditions. I'd say this is a fun project. Evolutionary learning is a very fun topic, but really, to be honest, there's not that many real-world applications where you can use evolutionary learning. It's really only used in gaming. Obviously, Elon Musk isn't going to put 50 Teslas in a car park and let them drive around crashing into each other so they can learn how to park. They're going to have to take a slightly different approach when they're working with real automobiles. So hopefully this has given you a good overview of the kinds of projects you can work on in artificial intelligence, and also the kinds of levels that you can consider using AI in your projects. You don't have to, have a PhD in maths and be, a Python guru to be able to work with machine learning. You can start at an easy level, working with cognitive services, working with other services, using pre-trained models and things like the custom vision service, and take an easy approach into leveraging AI in your projects. Okay, so we're going to be around for another few minutes if you'd like to ask us questions, or if you've got any comments on the session. Also, we will have additional sessions where we'll be going into a lot more depth on the technologies that we've been talking about in the different scenarios.
I'm not sure if I'm... Hello there. If you might be able to show, we actually have quite a lot of stickers. We're not able to send them worldwide, but please, if you live in Sweden, go to our website or scan this QR code, and we will send you a few nice stickers for targeted towards developers with things related to the technologies we have spoken about today. So please go there. And as Alan mentioned, there are a lot of there are 3 tracks, I think, we're running now, Erika, which both regarding AI, machine learning, cloud native, and DevOps, I think. But me and Alan are mostly involved in the AI, machine learning, and cloud native. And I just want to do a shameless shout out for my next session next week regarding democratizing AI using cognitive services. So that will solely focus on the cognitive services and the cool demos on what you can achieve with not having to know too much about AI. So that's that section. But I think, as you mentioned, Alan, I think, Erika, we have a few more minutes for Q&A, right? And there have been quite a lot of good questions during the session. But please write in the chat, and I will try to answer them.
Yes, exactly. So yeah, first, just let me say a big thank you guys. And I think nothing beats a bit of deep house during a live demo, just FYI. So yeah, thank you guys, and you guys who are watching, just drop your questions in the chat, and Alan and Peter will answer them. We have like 5 minutes left for that purpose. So yeah, I don't know if the questions that have been asked before, have you guys replied to them, Peter?
Yeah, I think we have replied to all the questions in the chat. If someone feels that we haven't, please write that question again. Someone asked about job offerings within this area. I'd say that me personally, I haven't explored AI specific jobs. I rather see it from my point of view. I use AI to enhance the software development I do, but I know there are a lot of companies working like purely with AI and machine learning. Now there's a lot of questions going in here, so I will try to answer them one by one.
I can put them here on the big screen. Wait, let me just catch up on the last one here.
Yeah. What about security and the APIs for cognitive services? How is that handled? Yeah, that's a really good question. So when working with cognitive services, I just move the question to the screen in front of me so I can look you in the eyes while I'm answering.
And I just remove myself.
Yeah. So here we go. Cognitive services works in a way that you need to be a consumer of Azure, which you can be, of course. You can, if you're not that today, you can start being that. You then create a service in Azure for, if you want to do computer vision, you create a computer vision service. And if you want to do speech recognition, you create a speech recognition service. And then you get API keys and you get ways to interact with your service. So if you want to analyze an image, you send it to your service and then you are billed for that. Is that... Please tell me if that was the answer to your question regarding security in cognitive services. What can be used for labeling text which is extracted from images? I'm not. Is Alan left in the call? I'm not sure if Alan is better to answer this one.
Can you hear me?
Yeah. No, I can't hear you. It's going back and forth.
Can you hear me now?
Oh, I can hear you. Yeah.
Yeah, I mean, the Azo portal in the computer vision basically provides the support for you for uploading images and labeling them. There are other tools where you can basically do this on premise, and also the Azo machine learning provides the capability to be able to label images and data sets as well.
And I think, Alan, you are the best one to answer the next question as well regarding any additional YouTube channels on the algorithm and framework level.
Yeah, I've mentioned that. I would say that Sendex is the best for the algorithms and frameworks. So the Sendex channel has a lot of stuff on Python. I'm just looking up the URL for this, and I'll drop it in because Harrison Kinsley is his real name, but he's done a ton of videos. So I'll just drop this in the chat: Python and AI. So most of the stuff I've learned on machine learning, I've learned from that Sendex channel. I'll see if I can find the audio stuff as well, because there was some good. If I can find it, there's a really good channel on the working with audio. If I can find that one. I don't know if you can take another question, Peter.
I can take the next question. And yes, I actually had to Google and see what's the latest status on that one. But at least some of the services supports managed identity. So for you who are not aware, managed identity is a way for letting your services authenticate against other services without using kind of credentials such as usernames and passwords or API keys. And while from initially you were only able to identify yourselves towards cognitive services using a key, basically an API key, but nowadays at least some of the services seems to support managed identity.
Yeah, so I dropped in the link there to the Sound of AI channel. That's basically where I learned all of the theory on working with audio and music classification.
I'm not sure if that you might have dropped it in the because I
dropped it in the YouTube chat.
Sorry.
I dropped it in the YouTube chat.
Okay, it might just be some eventual consistency. It doesn't show up for me yet, but it will probably get there any.
Yeah, I didn't have stuff dropping up in the StreamYard chat, just in the YouTube stuff.
Yeah. I think that was all of the questions. And regarding all of the thank yous, thank you for joining. And maybe we can show the last slide with our Twitter handles, because if you let me go back here and show that, if that's still shared. At least me, I'm available at Peter Örneholm at Twitter. So if you have if any other questions comes to mind, or if you want to follow me for when if I do some other stuff regarding AI, I will probably tweet it there. So feel free to follow me at Peter Örneholm. I think, Alan, you're also on Twitter, but maybe you're more active on your YouTube channel.
I'm just active on YouTube these days.
Yeah. So.
Can we get your YouTube handle? Oh yeah, there it is, Cloudcast. Yeah, I will just drop it in the chat as well. Carry on, Peter.
Yeah, it seems maybe you should try to post that link again, Alan, or maybe I'm not, because it says that other people says that they can't see your input, but it might also be that you can't post links in YouTube chat. I'm not sure.
Yeah,
maybe Alan, if you share the screen where you show that YouTube channel, it might. Oh, there it is. Cool.
No, that's me. So yeah, that's not the link that Alan wants to share. Nope. But yes, you can drop it, but it's not linked, so the people need to copy paste it. So it doesn't link, unfortunately, in the chat. But yeah, I'm just dropping as well to you guys, our viewers, 2 links here. And these are some modules from our speakers today, Alan and Peter. And you can follow. You can carry on. You can hear me, right? Yes, you can. Oh, I thought I was muted. Sorry. Yeah, so you can carry on learning on this path based on this, based on today's session.
Yeah, it seems that no more questions, right?
No, there's many saying that it was a great session, and I totally agree. It was not just informative, but really much fun. As I said, nothing beats a bit of deep house.
Yeah.
That was great. That was definitely great. So yeah, I was going to show my slides with the upcoming events, but you just did that for me, Peter. So thanks. Actually, let's put us back here now. Actually, I think you only showed, right? Yeah.
Oh yeah, I didn't have anything on the DevOps. So.
Oh yes. Yeah. So as I mentioned, we are now the Championing Azure collection series has 3 legs: AI and machine learning, cloud native, and DevOps. So on Tuesdays we have AI, on Wednesdays we will have cloud native, and on Thursdays we have DevOps. The next session is next Tuesday, and that will be with Peter from today, democratizing AI. And then tomorrow we are going to kickstart with the cloud native, and then we'll do an introduction to the cloud native options in Azure. On Thursday, we are going to be doing an introduction to DevOps. So yeah, in the next 6 weeks, I hope you're not busy on Tuesdays, Wednesdays, and Thursdays. No, just kidding. But yeah, but you can find all of our events upcoming on the meetup. Just make sure you register, and then you'll get to see and be with us here for the next 6 weeks. Yeah. Any more questions do we have? Somebody likes Alan's voice.
Yeah,
Thanks.
that's good.
Can you try for any next AI voiceover? Fun. Yeah, no more questions. Then, did we get the link from Alan?
No,
Yeah, I've dropped it in the YouTube a couple of times. I've dropped it in the stream link.
Okay, you've dropped it now there in the private chat. Let me drop it there. There it is. Is that it?
Yeah.
Yeah. So I've dropped it there now, guys. The link. So yeah, I think our time is up. So thank you so much, Alan. I will be seeing you a lot in the next upcoming 6 weeks. And Peter, I will see you next Tuesday as well.
Yeah.
Many thanks. Great session today. Have a nice evening. And you guys, from wherever you are in the world, have a great evening or a great rest of the day. I see you tomorrow or next week. Bye.
Thanks very much. Bye.